Hello everyone, this is Rangakuramia from Kisembo Academy, helping you manifest academic excellence, and in today's video, we'll be exploring the following. Stay tuned. A set is a collection of distinct items or well-defined objects or elements and can be represented by curly brackets or a Venn diagram. Today, we get to look at set notation. This is Kisembo Academy and thanks for tuning in. In some of the common set notations, we have this symbol representing the universal set. We have U, which is the union of, it represents union of. Then this represents intersection. This is the intersection of. Then this is a member of. C, this represents is a subset of. Then A complement means it's a complement of, or it can be B complement, meaning it's a complement of B. Then these curly brackets, when there's nothing in between here, means it's an empty set, or like that. An empty set is represented by this. Then if a set is not a subset of, it is represented by that. Then we have this is a set of real numbers, denoted by that. Then a set of rational numbers is denoted by that, and then a set of integers is denoted by that. We say that a set is a collection of distinct objects or well-defined objects or elements, and it can be represented by the curly brackets. These are the curly brackets I meant. And the set can be defined with elements that can be counted. These elements can be days of the week. If you're having a set of days of the week, a set of months of the year, we can have a set of people in a room, a set of boys that go to school, and those are finite, they can be counted. Then we can have a set can be infinite with elements that can't be counted. For example, if you're looking at elements like numbers, like odd numbers, you can't count all odd numbers and know all of them, even numbers and so forth. These joint sets are sets that don't have elements that are common. For example, here we have set A, 1, 2, 3, and set B is A, B, C. These are two different sets. They do not have elements that are common. Right before us is a number that we should do. They are telling us that if the universal set, this, remember in our previous video we encountered this as this notation as universal, it represents universal set. So the universal set is this. It means that all members of the set, both whatever sets there could be more than one set, all the members are represented by all those members in curly brackets. So within this universal set contains set A, which is 2, 3, 4, 5, and 6. And still in this universal set, we have set B, which is 2, 4, 6, 8, and 10. We're supposed to represent the above information in a Venn diagram. So we'll go right ahead and represent the information in a Venn diagram. That will be our Venn diagram. And our universal set, we represent that on top here. Our universal set, we do not know how many members are there yet, but we have set A and set B. So we'll have set A here and set B right there. They're telling us that set A is having those members and set B is having those members. So we have set A here and set B. These are two circles. Now if set A and set B are sharing any items, then it means that the items they are sharing have to be in the middle here. So we have to first find what are those intersections, those members that are shared between A and B. If you look at set A here and set B here, 2 is a common term. 3 is not here, 4 is shared. Then also 6 is also shared. So it means that these terms that are shared between A and B are supposed to go in the middle. They are in the intersection of A and B. So in the intersection we have 2, we have 4, and we have 6. Those are the elements that are shared. So the rest that are not shared go, set A for example 3 is not shared, so we'll put 3 there, and 5. Likewise in B, those that are not shared is 8 and 10. So we have 8 and 10. And there we have represented that information in a Venn diagram. But now, we do not know if all members have been, so we check with our universal set. So checking with our universal set, we do not have 1 in any of these. So it means set 1 is not in A, it is also not in B. So it is outside. 2 is there. 3 is there. 4 is there. 5 is there. 6 is right there. 7 is not represented anywhere. So it's not in A, it's not in B. So we put it outside as well. 8 is there. 9 is not anywhere. So it is also out. 11 is not anywhere. So we also put it out. Then 12 is also not anywhere. We put it out. So there we have fully represented our information. Roman 2 is telling us from the Venn diagram, find part A union B. This is how we represent it. So A union B, union means all members in the union set. All members that are joining A and B. So A union B is this, that, and that. So A union B is 3, 5, 2, 4, 6, 8, and 10. So those are members in A union B. That is part A. Part B is telling us that to find N into A union B. Now this notation means that they are asking us to find the number of members in A intersection B. Now in A intersection B, intersection means the members that are shared between two sets. So the members that are intersection are here. That is in the intersection. So in the intersection, the number of members in A intersection B are 1, 2, 3. There are 3 members. Then our part C, they are telling us that find the number of members in A complement. Now when they say A complement simply means that members that are not in A. So if you look at set A, the circle to set A is this. This is set A. And all the members in set A are inside there. Those are members in set A. Now when they say set A complement, it means they mean anything that is outside A. So the number of members in A complement are, so we shall count whatever is outside A, because that is what is representing A complement, and that will be 1, 2, 3, 4, 5, 6, 7. So there are 7 members that are outside set A. So those are 7 members. In shading set A intersection B, we need to first discover where the intersection lies. So we are going to first shade set A. Like that, using lines going in that direction. Then we shall shade set B, using lines moving in the reverse direction. In another direction. Now, the intersection is where these two sets are meeting. It means where these lines are intersecting. That is the intersection. So it means A intersection B is this middle part, because that is where these lines are crossing each other. So that is what we shall shade as our intersection. So this is set A intersection B. Then we have A union B. Union simply means the unity of the elements in both A and B. So this is the whole of set A. And this is the whole of set B right here. So where these two A and B are united, their union is a combination of elements in set A and elements in set B. So when they say shade A union B, they are talking about they mean that you combine all elements in set A and all elements in set B, and so we shall shade all members of the elements in set A and those in set B. So that is A union B. So let's investigate what is set A complement. Set A complement is what is outside A. That is what it means. So set A complement means you do not shade A, but you shade everything that is outside set A. That is set A complement. Set B complement means you shade outside set B. This is the whole of this is set B. So B complement is you shade everything outside B. Like that. Now we have set A intersection B complement. Here we are having set A and set B complement. Now in this case they want us to find the unity between set A and set B complement. So let's investigate where these two are joining. If you look at set A is just this. I'm shading set A. That is set A. And then set B complement is anything. B complement means the outside B. As in we are going to shade everything else, but we are not going to shade B. That is what B complement means. So B complement means anything outside B. And that is it. So if you realize here that the intersection, or where these lines are crossing each other, is the intersection that is shared between A and B. So it means A intersection B complement is where you see the lines intersecting each other, crossing each other. It means that where these lines are crossing each other is where these two sets are united. It's their intersection. And so as a result, set A intersection B complement is this portion where the lines intersect. And so this is now the true A intersection B complement. So we have set A complement intersection B complement. Same. Now A complement means that we shade everything else but A. So we shall shade outside A for A complement in that direction. So shading set A complement means you're going to shade outside set A and you're going to leave set A intact like that. And then B complement means you are going to shade outside set B. This is set B. So B complement means you're shading outside B and you're going to leave B without shading it. So we shall shade B complement in the reverse order, like that. So you discover that set A complement intersection B complement is where these lines are intersecting, and you find that they are intersecting outside. So that is the intersection. So the shading A complement intersection B complement means you're actually shading this part outside. So that is actually set A complement intersection B complement. Now set A intersection B intersection C. We have to investigate where this region lies, where all these sets are increasing. So at first we have set A, which is this one. Then we have set B, which is that one. Then we have set C. We shall shade it in a different form also, like that. So the lines for set A are vertical. The lines for set B are horizontal. Then the lines for set C are slanting. So you find that all these the three lines, the vertical, the horizontal, and the slanting, they are all intersecting in just one region. So in that region where they're intersecting is where all these sets are intersecting. So A intersection B intersection C is this middle part. And so if we are to shade that, it is this actually. That is set A intersection B intersection C. So A union B union C means that set A, set B, and set C united. So union, in their union, it means A union B union C is everything. You shade set A and set B and set C. That is A union B union C. Then we have A intersection B union A intersection C. So we have A intersection B first. What is A intersection B? This is set A and that is set B. So their intersection is this. So we shade it. This is their intersection. Then we have A intersection C. So we have set A and set C. Their intersection is, this is set A and this is set C. So their intersection is this middle part. So intersection C is also here. So when they say union, of course, union, it means you shade all of them. You shade this and that combined, which is this part and that part. So this is A intersection B union A intersection C. Then we have A union C intersection B union C. So when we are dealing with intersection, we need to discover where the lines are intersecting. Let's first shade A union C. This is A, this is C. This is set A and that is set C. So A union C means you're going to shade everything like that. Let's use vertical lines for A union C. A union C is that. Then B union C. We have B and C. So B union C means you're going to shade B union C, everything. So we should, for B union C, we shall use lines that are horizontal. B union C is that. So now the intersection of this and that is where the horizontal lines and the vertical lines are intersecting. And if you look here, the horizontal lines and the vertical lines are intersecting in this region, in this region, in this region, in this region. So they are intersect even in this region. So where they are intersecting is where the intersection is. So the intersection of A union C and B union C is actually what we are going to, which is that. Now, out of 35 students in a class, 26 play volleyball, 20 play ball, 26 play football, 20 play volleyball. Given that 17 play both games, how many play neither of the games? Let us summarize this question in a Venn diagram, in a rough one. If this is our rough Venn diagram, we are having out of 35 students, it means our universal set is 35. In a class, 26 play football. So those that play football are 26. So football is 26. 20 play volleyball. So those that play volleyball are 20. Given that 17 play both games, So in the intersection, when they say both games, it means both football and volleyball. So those ones are in the middle here, 17. They play both games. Given that 17 play both games, how many play neither of the games? So if 17 play both games, how many are playing neither? Those that do not play any of the games are outside the circles. Let's call them an unknown x. So our task here is to find this value of x. So if 17 are playing both football and volleyball, then in this portion here, we are having those that play football only. So to get how many are here, remember this 26 covers everything in this circle. So to get what is only covering just this portion of the circle, only this, it means it's going to be 26 minus 17. And 26 minus 17, we get 9. So it is only 9 people here that play football only without playing volleyball. Then the ones that play volleyball, we say they are 20. It means these 20 covers everything inside this circle. They are the people who play volleyball. But amongst the people who play volleyball, there are those who play volleyball and football, which are 17. And then those ones that play volleyball only, they are this section. And those ones are, we can get them by saying this 20 minus the 17. And the answer we get here is 3. So there are only 3 students here that play volleyball only. So it means that our Venn diagram is now going to look like this. So that's how our new Venn diagram looks like. These ones play volleyball only. These ones play football only. But 9 plus 17 gives you 26. 17 plus 3 gives you 20. It means that whoever is inside this circle plays volleyball, and these 17 here are the ones that play both games. These 2 don't play any of the games. And our universal set here, or the total number of students, is 35. So we are required to find the value of x. So to find the value of x it means this 35, we write it outside here, meaning that everything that is inside here should equal to 35. So to get the value of x is x plus 3 plus 17 plus 9 should be equal to 35. And that's how we're going to get the value of x. So it means that x plus 3 plus 17 plus 9 should give us 35. And our answer there is going to become x plus 29 is equal to 35. X is going to be equal to 35. This 29 goes that way, it becomes 35 minus 29, and we shall remain with our value of x as 6 students. So it means it is only 6 students that do not play any of those games. Let's go on to the next question. In our next question, they're telling us that a group of 20 girls, in a group of 20 girls, so meaning 20 girls, meaning this is our universal set, there are a total of 20 girls, 16 play football, 12 play hockey, and 2 play neither of the games. Find the number of girls who play both games. Let's summarize our information in a rough Venn diagram here. So in a group of 20 girls, so meaning our universal set is 20 girls. That's the total. 16 play football. So those that play football are 16. And then 12 play hockey. So those that play hockey are 12. 2 play neither of the games. So 2 people do not play football, they don't play hockey, so they are not inside these circles. So these 2 is outside. 2 play neither of the games. Find the number of girls who play both games. So the intersection, the ones who play both football and hockey, they are here x. So they're asking us to find the number. So we can first begin by filling this gap and that gap. This gap here, we know that whoever is inside this circle is playing football. So those who play football only is going to be this total, which is 16, minus those who play also hockey. So it's 16 minus x. Then even here, those who play hockey is the total. In this circle, they are 12. But those who play hockey only, this portion is going to be 12 minus x minus the people who play both games to get them. So our task here is to find the value of x, because the value of x here is the number of girls who play both games. And we shall get it by saying it is 2 plus this plus that plus this plus that plus this is equal to 20, which is the total number of girls. So we begin. So it's going to become 20. 2 plus 12 minus x plus x plus 16 minus x is giving us 20. So this is going to become 12 plus 2. So this is going to be 30. 30 minus x is equal to 20. So you remain here with negative x giving you 20 minus 30. Of course, here our value of x here is going to become 10. So it means our value of x is 10. So if our value of x is 10, it means the number of people who play both are 10. So it means our Venn diagram here is 16 minus 10, giving us 6. And here 12 minus 10, giving us 2. And so our Venn diagram will change to this. So that becomes our new Venn diagram. In a certain school, there are 50 students who play 3 games. Before we've been dealing with 2 games, now we're dealing with 3 games. 3 games, namely chess, tennis, and volleyball. 24 play chess, 26 play tennis, and 29 play volleyball. 9 play both chess and volleyball. 13 play both tennis and volleyball. 11 play both chess and volleyball. Each of these students plays at least one of these 3 games. Now, when they say that each of these students plays at least one of these 3 games, it means that all of them play at least one of the games. It means no one doesn't play. All the students, all these 50 play at least a game. So represent this information on a Venn diagram. That's going to be our first task. We interpret this question into a Venn diagram before we can answer any other questions. So this is our Venn diagram. In this Venn diagram, we have 50 students. So our universal set is 50 students. And these 50 students, they are playing 3 games. And these games are chess, tennis, and volleyball. So we shall say it is chess, tennis, and volleyball. So chess, tennis, and volleyball. 24 plays chess. When they say 24 plays chess, it means that the total number of people playing chess is 24. So those that play chess is 24. Then 26 play tennis. So those who play 26 is tennis. We put it up there. And 29 play volleyball. So those who play volleyball are 29. 9 play both chess and volleyball. So if it is both chess and volleyball, they are 9. Now what does that mean? It means that the intersection of chess and volleyball is there are 9 students. Now these 9 students are including even these ones that are playing tennis. So they are 9. So we can't write it here, because when we write the 9 here, it would mean that is chess and volleyball only, without including volleyball, without including tennis. But they're telling us that those that play volleyball and chess are 9. So those that play volleyball and chess can also include those that also play in this part where they are both playing chess and volleyball, but also tennis. So we shall put this line 9 here momentarily. So those 9 play both chess and volleyball. Let's put that 9 right there. Then 13 play both tennis and volleyball. So both tennis and volleyball, it's the same story. They are lying in this whole group. So there are how many? 9. 9 play both chess and volleyball. 13 play both tennis and volleyball. So we put the 13 right there, temporarily. Then 11 play both chess and tennis. Those who are playing both chess and tennis here are 11. So we put it there. Now, if the question had told us that 9 play both chess and volleyball only, so it would simply mean that those who play chess and volleyball only are just this part. and we'll put them there. If they said those 13 play both volleyball and tennis only, that word only, it would mean that this 13 is supposed to be put here. Now, since we know that this 9 represents everything inside here, this 13 represents everything here, and this 11 represents everything in the intersection here, we need to feed these figures in. So, we know that there is a certain number of students who play all the 3 games. We do not know how many of these are. So let's call it x. If this is a value of x, the number of students who play all the 3 games, it means that in this portion, therefore, we can say it is 9 minus x. Then right here, it's going to be 13 minus x. And then right here, it's going to be 11 minus x. Now, this we are trying to interpret the question in the Venn diagram. So it means that we need to, for us to effectively represent this information in the Venn diagram, we need to first find this value of x. And then when we find the value of x, then we are able to represent everything in the Venn diagram. So if this is 9 minus x, 11 minus x, it means now this is out. So now we have these gaps that we still need to fill. This is P, well, let's call them letters, P, Q, and R. So the value of P here is going to be, we get this circle, it is 24. The number of people who play chess is 24. So to get these people that play chess only, these are the people who play chess only. So the people who play chess only is going to be 24 minus these, because this is the whole circle. So we are supposed to get the total, which is 24, minus these people who are playing tennis and volleyball, so that we only remain with P. Likewise, Q, for us to get this value of Q, the number of people who play tennis only, it means you're supposed to get the 26, the entire circle, minus those ones, minus this, to get Q. It's the same thing with R. So let's compute for the equivalent of P, Q, and R. So our value of P here is going to be, P is going to be 24 minus this plus that plus that. So it's 24 minus 11 minus x plus 9 minus x. And that's going to be 24 minus, that is this and that will go, so we have 20 minus x. So this will become 24. When we open brackets here, this is negative 1 times 20 is minus 20. Negative 1 times negative x is plus x. We shall remain with our value of P as 4 plus x. So P is 4 plus x, so here meaning that our value of P here is 4 plus x. So we get the value of Q. For us to get the value of Q, it's going to be this whole circle, 26 minus this, that, and that, so that we get what is remaining here, Q. So our value of Q here will be the total, which is 26, minus the remaining. So it's 26 minus this plus that plus that. 11 minus x plus 13 minus x. And that's going to become 26 minus this goes with that. So that's going to become 24 minus x. That's going to become 26 minus 24 plus x. So 26 minus 24, that gives us 2 plus x. So our value of Q here is going to be 2 plus x. So we go ahead and find our value of R. Our value of R, it is going to be 29 minus this, that, and that. So R is going to be 29 minus 9 minus x plus 13 minus x. So that's going to become 29 minus 22 minus x. So we shall end up here with 29 minus 22 giving us 7. This and that is plus x. So our value of r here is 7 plus x. So we formulated our Venn diagram. It is having all these gaps filled. We said according to our question there is nothing outside here. All these students play at least one of the games. So we need to compute and get for the value of x. So we are going to add all these regions, this plus that plus this plus that plus this plus that plus that is equal to 50, and then from there we shall get a value of x. So it's going to become, so we compute, this is, you are going to add everything here and equate it to 50. So it becomes 4 plus x, which is that, plus 11 minus x, which is that, plus 9 minus x, which is that, plus x, which is that, plus 2 plus x, which is that, plus 13 minus x, which is that, plus 7 plus x, which is that, and all this is equal to 50, which is that, is equal to 50. So when we compute all this, we end up with 46 plus x is being equal to 6. 46 plus x is equal to 50. So 46 plus x equal to 50. When we collect like terms and we make x the subject of the formula, we get our value of x as 4. So when we get our value of x as 4, it means that our Venn diagram, now we've got the value of x. So it means that when we start filling in 4 plus 4, this will become 8. 11 minus 4 is 7. This is 2 plus 4 is 6. 13 minus 4 is 9. This is x is 4. Then 7 plus 4 is 11. 9 minus 4 is 5. So it means our new Venn diagram is going to look like this. That becomes our new Venn diagram with our total being 50, the total number of all students here that are playing chess, tennis, and this is definitely volleyball. So that's our new Venn diagram. So we proceed with the question. They told us to represent the information on a Venn diagram, which we have just done. Then Roman 2, they're telling us Roman 1, find how many students play all the 3 games. Now the students that are playing all the 3 games are those ones, 4. We already calculated that. Roman 2, the number of students who play only one game. Now the number of students who play only one game are these ones. 8 plus 6 plus 11. These 8, they play chess only. These 7 are playing chess and tennis only. These ones play only 2 games only. These ones play all the 3 games. So 8 plus 6 plus 11. These ones are the ones who play only one game. So the answer to that is 8 plus 6 plus 11. 8 plus 6 plus 11 gives you a total number of 25 students who play only one game. Then Roman 3, they're asking us to find the probability that a student selected at random plays only tennis. So those students who play tennis only are 6. So the probability is going to be equal to the number of students who play the game divided by the total number, which is, or which of the students who play the games, which is 250. So it means the probability is going to be equal to 6 over 50, which is going to end up 3 over 25. That's the probability that a student selected at random plays only tennis. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakurame helping you manifest excellence.